Okay, so let's take a look at your homework. I had asked you for homework to do numbers 5 through 7. So for problem number 5, it's asking you to decompose x squared plus 8 over x to the third plus 8. Now, first thing we have to do is factor. So it's same sign, opposite, always positive. You might have to refresh if you don't remember your special cases, but this will be a over x plus 2 plus, well, we have a quadratic, x squared minus 2x plus 4. This will be bx plus c. So if we multiply by our least common denominator, which will be x plus 2 times x squared minus 2x plus 4, we'll get x squared plus no x plus 8 is equal to a times x squared minus 2x plus 4 plus bx plus c times x plus 2. Let's distribute this out. And we'll group our x squared terms. We'll group the x terms. And then we'll group our constants. So the total number of x squared terms has to equal 1. The total number of x terms has to equal 0. And the total number of constants has to equal 8. So now we'll solve this system. Looks like if we could eliminate the c's here, we'll just have an a and b equation we can combine with the top. So I'll multiply the top by -2. And we get 8a minus 4b is equal to 8. And I'm going to multiply this top equation by negative, let's do positive 4 to eliminate it with the b. We get 12a is equal to 12. A would be 1. And if a is 1, b would be 0. And let's see, 4. So that's 4 divided by 2. C would be 2. All right, so that should be the answer for number 5. All right, as far as our actual decomposition, we would say that x squared plus 8 over x to the third plus 8 is equal to x plus 2. The other one's going to be x squared minus 2x plus 4. This will be 1. B is 0, so there's no x, and then you're just going to have 2 over here. That's where that comes from. We'll do the next one, problem number 6. So problem number 6, it says we have 4x squared plus 2x minus 1 over x squared times x plus 1. So the x squared is a repeated factor. We're going to have an x, we're going to have an x squared, and then we're going to have an x plus 1. X is the actual factor, not the x squared. So this will just be a, this will be b, and this will be c. The reason why this isn't bx plus c is because the factor is x. Right? It's not x squared. It's a little bit different than the one above it. Alright, so the LCD would be x squared times x plus 1. Let's see what we get here. 4x squared plus 2x minus 1 is equal to a times x plus 1 plus b times x plus 1 plus c times x squared. So we'd get ax squared plus ax plus bx plus b plus cx squared. So the total number of squared terms, a plus c, the total number of x terms, a plus b, and now let's figure out what they are. So a plus c has to equal 4, a plus b has to equal 2, and b is negative 1. Alright, so if b is negative 1, plug that in and get a is 3. And if we plug that in, c would just be 1. And then we could just write our decomposition there. Okay, one more, number 7. Number 7 says we have x squared over x minus 2 times x minus 3 to the second. And that's going to decompose to a factor of x minus 2, 1, the first power of x minus 3, and then the second power of x minus 3. So once we multiply up our least common denominator of x minus 2 times x minus 3 to the second, we'd get x squared plus no x plus nothing is equal to a times x minus 3 to the second plus b times x minus 2 times x minus 3 plus c times x minus 2. Let's distribute. We get ax squared minus 6ax plus 9a plus bx squared minus 5ax plus 6b plus cx minus 2c. Group our x squared terms together. Group our x terms together. Let me see, I think I might have made a mistake over here. It's minus 5bx. And then we have the c. And then we have our constant terms. So the total number of x squareds is 1. Get negative 6a minus 5b plus c is equal to 0. And 9a plus 6b minus 2c is equal to 0. I'll eliminate the c's by multiplying this top equation by 2. And I'll multiply this top equation by 3 to eliminate the a's. And I get b is equal to negative 3. If b is negative 3, that means that a is 4. And if we were to plug those in, we get -3, 4, and c would equal 9. So that would give us the partial fraction decomposition. All right, have a nice day.